A scanning electron microscope is a type of electron microscope that produces images of a sample by scanning the surface with a focused beam of electrons. The electrons interact with atoms in the sample, producing various signals that contain information about the surface topography and composition of the sample. The electron beam is scanned in a raster scan pattern, and the position of the beam is combined with the intensity of the detected signal to produce an image. Insert the key and turn it to the start position to start the system. Releasing the key stops the key at the on position. Returning the key to the off position shut down the system in a few seconds. Then we have evac switch. This switch introduces air into the specimen chamber. The built-in light comes on when the specimen chamber is at atmospheric pressure. When the air is being introduced, the light blinks. To start the program, select all programs, then select PC SEM from the start on the taskbar. It will open a dialog box, and there you need to enter the login and password details to enter into the software. The next step is mounting a specimen. Place the sample on the sample holder. So this is called as multi-holder since there are multiple plateaus, and any one of these 14 plateaus can be selected in order to bring the plateau to that particular focus position. Usually with the help of the tape, we stick the sample in the multi-holder. So while mounting a specimen, it's better to avoid using an excessive amount of conductive paste. Ensure that the paste has dried before placing the specimen in the chamber. When using a double-sided adhesive tape to fix a specimen to the stub, use the least possible amount so as to minimize out gassing. Mounting a specimen containing an excessive amount of water or oil can cause contamination in the column, which should be avoided. Various types of specimens like conductive specimen, non-conductive specimens, biological specimens, X-ray analysis specimens, etc. can be mounted. Then apply the accelerating voltage from the top left corner, VACC on. VACC means accelerating voltage in the electron gun, and IE is the emission current. The run button used to run or freeze the scanning. To stop scanning, click the button. Scanning continues until it reaches the end of the frame and then stops. During this time, the display in the upper left section of the image shows going to freeze. And after the image stops, the display shows freeze. The other four buttons provided, TV1, S2, 1 and S3, these are scanning speed. There are 14 scanning speeds assigned for 4 buttons. TV scanning of flicker-free images is convenient for a field search of the specimen, coarse focus, etc. The quality of the image is improved by frame averaging. Fast scanning runs with half the speed of TV scanning. It is also convenient for a field search of the specimen, coarse focus, etc. This is the highest possible scanning speed under the full screen mode. Then we have slow scanning. Here slow scanning 1 is about 0.5 seconds per frame. Slow scanning 2 is about 2 seconds per frame. Slow scanning 3 is 10 seconds per frame. Slow scanning 4 is 19 seconds per frame, and slow scanning 5 is 38 seconds per frame if it is small screen. In full screen, these speeds will vary. Next panel is the auto control panel. ABCC is to start auto brightness or contrast control. AFC is to start auto focus control. When magnification is lower than 5000x, coarse focus is carried out, and when fine focus is carried out at magnifications above 5000x. Fine focus works correctly under conditions where the image is not clear but visible. The result of autofocus depends on the surface structure of the specimen. When there is little or no surface detail on the specimen, or when the specimen is charged, autofocus will not operate properly. ASFC is the auto stigma and focus control, which is automatically corrects the stigma and focus. Align is to open alignment dialog window and start aperture alignment. Then we have magnification indicator window, which is indicating magnification. In this window, moving the mouse while holding down the left or right button changes the magnification. To increase magnification, drag the mouse to the right. To decrease it, drag it to the left. Then we have capture control, which captures an image with pre-specified image resolution and scanning speed. The displayed figure on the capture button indicates the resolution of the captured image. At the bottom we have captured image restore window. Here we have save button to save the selected image, delete button to delete the selected image, all button to select all the thumbnail button, view button open the selected image on the viewer window. Then we have layout button opens the report generation window for printing the image. Cond button opens the ope.cond tab of the setup dialog box. Photo button starts memory photographing of the selected image. Move button to move the stage to the position where the selected image was captured. And PCI button transfers the selected image to Quartz PCI database program. Brightness means the value of each of the individual pixels that comprise the image. The higher the overall pixel values, the brighter the image. Contrast means this is the difference between two pixels. The overall contrast is the difference between the lowest pixel value and the highest pixel value. So always optimize the brightness and contrast to what you need to reveal. Ideally, the brightness and contrast should be set so that no face is oversaturated, which is around white, or undersaturated, a kind of black. Increase the contrast to highlight, for instance, a discrete compositional zoning. Image shift X and Y is to move the sample plate to either X or Y direction. We have already seen there are around 15 plateaus, so for which any one of the point it can be focused. So through this X and Y we can move that one, or through the joystick also we can move it to either X or Y direction. Range of movement in X direction 0 to 100 mm, Y direction 0 to 50 mm, Z direction 5 to 65 mm, rotation 360 degree continuously, and tilt minus 20 to 90 degree. Magnification, it is a function of area scanned and viewed. Two controllers adjust the magnification, the raster coils, and the location of the focal point of the primary beam to the final lens. So these are the two ways the magnification is adjusted. And then we have the focus from coarse to fine. So there are two knobs, one is for coarse focus and the other one is for fine focus. And the rotation, the sample holder can be rotated manually using this small rotation knob, or else in the screen there is rotation. So by clicking plus or minus direction, the rotation can be made. If you feel that the sample is not straight or it's not covering the required area, you can rotate. Adjust the focus, magnification, contrast, brightness, etc. until you get a clear image on the screen. You can also vary the scanning speed to scan. Once you obtain a clear image on the screen, click the Run Freeze button. So the scanning image will be frozen and image capturing will take place. This capturing process stores images using specified scanning mode and specified resolution. Then you can save the image. This would be displayed in the bottom. After we export the image, we can move to find the elements which are present in that particular image. So here we have a right hand side panel and a left hand side panel. From the right hand side panel we can set the magnification, width, height, etc. And from the left hand side panel we can call the elements which we are expecting which would be present on that. Even if we are not selecting the elements, it will show, but in case if we are expecting something, then we can select these are the elements we are expecting, that will show it. So it will show the periodic table. We can select one by one. So here in my case I need titanium, magnesium, manganese, aluminium, carbon, cobalt, silicon, etc. It does not mean that it will show only the elements which we select, but it will show the elements which we select as well as the elements which have nearest energy besides the elements we select. To find the elements, either we can select an area or we can select particular points. Both will work. This setup is available on the top, as you can see here. So here I have a drill bit. So I want to know if there is any particulates from the workpiece which is stick to the tool. So I'm just selecting mostly the edges which are showing kind of different colors. Once it's done, it will show you the report. You can save it and you can export the report. And also from the results it's showing, you can delete the elements if you know them should not present. So here in case say for example bromine, I know bromine should not be here because according to my workpiece bromine should not be here. So in such cases, if you are 100% sure that element should not be there, then you can delete as well. So why bromine is appearing here is it has the energy near to aluminium. You see here aluminium and bromine, they are very near, so which means they have energy levels closer. That's why the bromine is appearing here. So it's actually should be aluminium, so I am deleting the bromine. Once everything is done, you can withdraw the specimen from the specimen chamber. For that, on the EVAC panel located on the front side of the main unit, press the AIR button, or else click the AIR button located in the upper right section of the control panel. This introduces air into the specimen chamber. Wait approximately for around 2 minutes until the specimen chamber is completely at the atmospheric pressure. Then grasp the handle of the front side of the specimen stage, pull it towards you and take out the specimen. When removing the specimen, be sure to put on clean gloves. Do not use a bare hand.